Hi everyone. I'm going to explain about the Prim's algorithm in data structures and algorithmic techniques. So the greedy method, many algorithms will be there. So already we have seen about binary search, linear search, Kruskal algorithm, everything. So now we are going to see about the Prim's algorithm. So in the greedy algorithm, very important algorithm is a Prim's algorithm. So the definition of the Prim's algorithm is it is a graph-based algorithm and it is used to find the minimum spanning tree of the given graph and is also used to find out the shortest path between the two vertices or 2 points in the graph. So before that, we should know about what is the spanning tree. So here spanning tree means it is a connected graph G that can be defined as a manner that is a set of edges of G that contains no cycles and also it contains a minimum cost in the set of edges that should connect all the vertices. This is called as a spanning tree. So minimum spanning tree means it is a tree that it covers all the vertices and it contains vertices minus one edges and total cost also is in the tree is the minimum among all the possible spanning trees and it is not necessarily unique value. So the algorithms, Prim's algorithm steps they given for to implement the Prim's algorithm in the particular connected graph. So first point we have to start with we can start with any vertex of the graph. That may be first vertex or any other vertex. And the second one, we have to select the minimum cost edges and add the edge to the graph if it is not forming the cycle. If it is forming the cycle, then we can omit or discard. So third step, it repeat the step 2 until all the vertices are allowed. So these are the steps we need to follow when we are finding out the minimum cost value using the Prim's algorithm. So here they given one example. So here 7 vertices are there and edges also they given. Each and every edges have contained the weight value. So this is called as an spanning tree, weighted spanning tree. So here find how to find out the minimum cost value in the spanning tree. So using this graph, we can select any vertex. So first I have selected the first vertex. I'm going to select first vertex that is 1. So from 1, two adjacent vertices are there. One is 1 to 2 and another one is 1 to 6. So which one is the minimum cost? So having the minimum cost edges, that is a 10. This is a 10 compared to 28, 10 is a minimum. So we can select 1 to 6. So the value is 10. The next we can select from 6. From the 6, two edges are there. One is a 6 to 1, 6 to second one is 6 to 5. So already we have selected 10. So now we have to select only 6 to 5. That value is 25. So that we have selected. Now from the fifth vertex, so these three vertices are connected from 5. So one is 6, another one is 7, another one is 4. So in this among 3, we have to find out which one is having the minimum cost. Here 5 to 4 is having the minimum cost. So we can select this edges. So we can connect from 5 to 4. Now we need to check whether it is forming the cycle or not. So it's not forming the cycle. That is open only. Now from 4 we need to check. From the 4 again 3 vertices are connected. One is 7, another one is 3, another one is 5. So already we have selected 22. So only there is the two options will be there. One is 7 and 3. So 7 is containing 18 cost value and 4 to 3 the weight cost value is 12. So which one is the minimum cost? That is a 12 only. So we can select 4 to 3. So again we need to check whether forming the cycle or not. No. Now from 3, only 2 edges are there. Already we have selected 3 to 4. Now we can select only 3 to 2. That is 60. From now 2 to 2 to 1 means that will form the cycle. So 2 to 3 also already we have selected. Only one options will be there, that is 2 to 7 only. So if we select, it will form the cycle or not, we need to check. If it is not forming the cycle, so we can select this one. 2 to 4 is 14. Now 2 to 7 is 14. So now we need to check whether all the vertices are connected with edges, and so 7 vertices, so 6 edges should be there. So see here 1, 2, 3, 4, 5, 6. 6 edges are there, 7 vertices are there, and it's not forming the cycle. So again, if we are checking 7 to 7 is connected with 2 and 20, 5 and 4. So if again we are checking the minimum cost value, when we are checking the minimum cost value, the minimum cost value will be from 7 to 4 only, 18. If you join this one, if you connect this one, it will form the cycle. So we can no need to, we cannot connect, and no need to connect this one, because no, already all the edges will be there, will be there, all the edges are connected. So it has contains the minimum cost value. So no need to connect this one. So we can discard this one. Then the remaining values are there. So now it is connected, right? So now we can find out the minimum cost value. So how to connect minimum cost values? All the edges we have to add. The weight value will be given now, each and every edges. So we have to add all the minimum cost value. Then finally you will get the total number of minimum cost value for the spanning tree. So it's 10 plus 25 plus 22 plus 12 plus 16 plus 17. So total equal to 99. This is the minimum cost for the particular this graph. So in this way we can find out the minimum cost value for the connected graph, connected weighted spanning graph, spanning tree graph. So in this way we can find out. So only one thing we have to remember. First one, we can start from any vertex, and we have to select the vertex that should not form the cycle, and we can calculate the minimum cost value. Thank you.